Welcome to Demystifying Math. In this lesson, we're going to be solving equations using logarithms. A logarithmic function is the inverse of an exponential function. The logarithms help us to solve for an unknown exponent. In the equation below, a is the base and y is the exponent. So if we rewrite that in exponential form, we get a to the y equals x. So, for example, if you're given log base 2 of x equals 3, that's the same as writing 2 to the third equals x. So x must be 8. If you have log base 5 of 125 equals y, you would first start off by rewriting it in the exponential form. So 5 to the y equals 125. Then you have to figure out what 5 to what power is 125. So that would be 3. So your answer is 3. Let's solve for x in this equation. 3 to the x equals 12. In this case, your exponent is not going to be an integer, so it's not easy to guess the answer. So what we're going to do is take the log of both sides. And I took the log in base 10, or the common log. And then I'm going to use the power property to get the x in front of the log of 3 rather than being in the exponent. And then I just need to isolate x. So I get log 12 over log 3. And then you just put that ratio in your graphing calculator or any calculator, and you get 2.26. You can always check your work by going back to the original equation. 3 to the power of 2.26 is almost 12. It's going to be a little bit off because we're rounding the numbers, but it'll be very close to 12. For our next example, we have 2 to the x minus 1 plus 4 equals 19. For your first step, you're going to isolate the term that has the variable in it. So we're going to bring the 4 over to the other side. Then we're going to take the log of both sides. So you have log of 2 to the x minus 1 equals log of 15. Then I brought the x minus 1 in front using the power property. Now I'm going to isolate the x by dividing by log 2 and then adding 1. And then put that into my calculator, and I got 4.91. So to check your work, go back to the original equation and plug in 4.91. Put it in your calculator, and you should get a number very close to 19. For our next example, we have 4 times 3 to the 2x plus 3 plus 5 equals 29. So again, we're going to isolate the variable term by bringing the 5 over to the other side, so I got 24. And then I divided by the 4. So I've isolated the term with the variable as an exponent. Now that I did that, I can take the log of both sides. Then use your power property to bring the exponent in front of the log. Now we're going to isolate the x term and then use the calculator to get the answer. So I divided by log 3, and I'm going to subtract 3 and divide by 2, or multiply by a half. Then I simplified it a little bit by distributing the half. And put that in my calculator, I got negative 0.684. Again, I'm going to check my work by going back to the original equation and plugging it in. And I got a number pretty close to 29. The more decimals you take it out to, the better off your answer is, or the closer it is to the 29. For this example, we have 5 to the x equals 3 to the x plus 1. In this case, both sides have exponents that are variables, and we're just going to take the log of both sides. Then use the power property on both sides, so we have x log 5 equals x plus 1 log 3. Then I distributed the log 3, and now I'm going to bring my x terms together and factor out the x. Now divide by what x is multiplied by. Estimate that answer in your calculator. I got about 2.15, and of course check your work. For our last example, we have 5 to the 3x equals 11 to the x plus 3. This is very similar to the last problem, so we're just going to take the log of both sides. And I'm using the natural log, but you could do base 10 as well. We use base 10 and base e because those are the keys that we have in our calculators. Any of the other bases, the majority of the calculators don't have that. So we're going to use our power property again. So we have 3x times log 5 equals x plus 3 times log 11, and distribute. Now we want to bring the x terms to one side, so we're going to subtract the x log 11 and then factor out the x. Then divide. And estimate using your calculator, and I got 2.96. And then check your work, and you should get 2 equivalent answers. Okay, thank you for tuning in to Demystifying Math.